So review for chapter for test 1 from chapter 1, 2, 3, and 4. So chapter 3, we are only going to cover matter and temperature, but we are going to leaving out energy at this point. So this is all theory. You should know about the matter. You should know basically what is the meaning of pure substances. Pure, what are pure substances? Pure substances are not mixed, like not impure. So pure substances are of two types. What are the two types of pure substances? Two types: elements and compounds. Okay, elements and compounds. Now, very important, what is the smallest particle of an element? The smallest particle of an element is atom. Atom, the smallest particle, okay, which contains the physical and chemical properties, the composition of a substance, atoms. And the smallest particle of the compounds is what? It is molecules. molecules. Okay, molecules. All right. So the smallest particles. Example of atoms can be like for example, gold, Au, like silver, right? Copper, iron, right? Aluminum. So kind of commonly used. You've seen all of them. So these contain only one type of particles. Molecules contain two or more atoms. But two or more atoms that are chemically combined in a very definite ratio. So chemically combined and in a very definite ratio, combined in a definite ratio, very specific ratio. Okay, and what is that? For example, you have here, for example, H2O. So two atoms of hydrogen and one atom of oxygen will give you a substance that has very specific properties. When you drink it, you live. But H2O2 is 2:2, but it's always a simplified whole number. So it's 1:1, hydrogen and oxygen. So this ratio, always, whenever it is in that ratio, 2:2, 1:1, right? It is going to give you a very poisonous material. When you drink, you can die. Same example is, for example, carbon with oxygen. Okay, so if you have one of carbon and two of oxygens, in that case, you have carbon dioxide, a very specific, properties. But if you have carbon 1:1 ratio, one of carbon and one of oxygen, a totally new substance. That's carbon monoxide, very poisonous. Carbon dioxide is also, but carbon monoxide is more, right? So if you have carbon monoxide poisoning at home, that can affect you. Okay, so that's one piece. So that's the pure substances. Now, then comes the mixtures. So you should know the mixtures are of two types. Mixtures. Okay, mixtures are two types. One is the homogeneous mixtures and the other is the heterogeneous mixtures. Homogeneous is they look same, look the same, right? Look the same. Like for example, in this, let's say sugar, and you can try this at home. Add white sugar and salt, so it's all looks one, right? So it's the, you can like look just by look, but the amount can vary. Okay, mixtures are impure substances, and they are like their amounts can vary. How many and how much, right? So you can have a pinch of salt in a large amount of sugar, or you can have 50-50, or you can have 75. Okay, then is the okay, that's fine. Okay, if you have to leave, it's okay, you can just leave a note here. All right, next is the hetero. You can see two or more substances can be seen, two or more substances can be seen to the naked eye. Like, for example, you have, let's say salt plus wood, right? Plus, you can add some paper into it, you know, put some sand into it. So you can see all these individual components, and it can vary, you know, so those things. So you should be able to, you know, do that. Then, the states of matter, the properties of matter, you should know. And this is a very easy chapter, basically, but just, you know, so this is pure substances, mixtures, and then you should just know the different states of matter, and you should know the phase changes. What are those called? Okay, so just review them on your own. I'm not going to cover this now. Phase changes, you know, what is boiling, what is melting, what is freezing, you know, what is what is it called, the names, you know, what is sublimation. So like, yeah, generally, like, sublimation is a new thing. Sublimation is when a solid converts to gas. Increase the temperature. Okay, so that's something, you know, new. All right, next comes the thermometer. So 3 and 4 is the temperatures. Okay, temperatures, again, I'm not going to cover this. We covered a lot, but the formula, now the thing, formula, write the formula, write the units, and show the conversions, the steps. So this is, you know, you need to do this for all the problems, all the math problems, the way I've been showing you. Okay, so here you see the, for example, you have for the Fahrenheit, if you are given the temperature in Celsius, degree Celsius, then PEMDAS. So always, if you, let's say you are given 1.8, so write down 25 degrees Celsius, okay, plus 32. So what will you do? You're going to do multiplication first, do this first, and then add, then add. So we are checking whether can you do the PEMDAS, okay? And that, so in this case, always very important that you write the unit. I'll deduct points if I don't. 25 by itself means nothing. So write the unit of degree Celsius, okay? If that's not shown, I'll deduct points. So that's one piece, okay? So that's an easy stuff. All right, let's move to chapter 4, which is very important. And that is the, chapter 4 is on electronic configuration, mostly. Chapter 4 on atoms, okay? So history of atom, you can leave, it's not that big of a deal. But the important thing is the electronic configuration and some of the things. Now, I already told you, oh, of course, yeah. The things that you need to know are the, number 1 is the symbols of the elements, symbols. So the common elements and their symbols. So you need to just have them memorized. I mean, memorized. So you really, there's no choice on that. Okay, so you are allowed to use the handout, and you know, on the periodic table, I have a little. So kind of, if you looked at the periodic table, you see in the periodic table, you know, where are the elements. And then, like, on the exams, if you need to see the elements, you kind of like look at, like, you know, you've already seen it before, so you know where to look at, and then, you know, go from there. So in the periodic table, there are certain things you need to know. What are the important things are that metals, know where are the metals, non-metals, know all the non-metals. There are just handful of non-metals, actually, not many, handful of non-metals. And then know the metalloids. Where are they located? The metalloids are on the step ladder, right? Non-metals are on the right-hand side. Metals are all on the left-hand side. Okay. Then you should know which period an element is located. You should be able to find that, and you should know which group. So group is vertical and period is horizontal. Okay. Then you should know the names of the groups, right? Names are halogens, which group? The non-noble gases, which group? Alkali metals, which group? Okay. Then you should know the other thing is, once we look at the atoms, then you should know the blocks. You know, the S block, P block, D block, right? Those things from the periodic table, know that, right? And then you should know the placement. The placement is basically, we are looking at the period number, and then we are looking at the block in the period, which block? SPDF. And then we are looking at the column, the number of column, a column number in the block. Okay, column number in the block. So that's the placement. Okay. Next is a very simple ones are like, you should know the atomic number, okay, and the mass number, and know how to calculate the number of protons, electrons, neutrons. Okay. Then average, now this is going to be a question on this, average atomic mass of the isotopes. Average atomic mass of the isotopes. Now, what is that? Average atomic mass. Let's do a question on that one. Now here, I'm just letting you this up front. Average atomic mass of the isotope, whether it's given or not, you are calculating. You will have to do it using the significant figures. All right, because it has to be based. So let's do a problem based on that. Isotopic mass. Okay, let's do this one. 4.39. Okay, 4.39 problem number. And here you have the, sorry. So this is one problem. 4.39, and this is on page 121. Page 121. Okay, so here we have two isotopes of gallium. Okay, gallium. Gallium, the symbol is Ga. Okay, gallium. The two isotopes of naturally occurring gallium at, okay, so here is the one. One is at the one that is gallium, okay, 6931. So this one is 60.11% off. Off means multiplied. 68.93 atomic mass unit. This is present in nature. And then gallium 7131 is present in 39.89%. Multiply by 70.92 AMU. Okay. Calculate the atomic mass using the weighted average method. So here, what will we do? We are going to, next is, let's just do this here, AMU, because I need space. Okay, now, as I said, we will have to use the, so I'm just telling you, guaranteed, there is a question on this. And I'm going to look at all the details as I'm talking to you about. Okay, this is a test question, 100%. I mean, everything that I'm discussing is going to be on the test, but this one is guaranteed. Okay, now here, let's do this. So we have here Now, okay. Things to note. 4 significant figures. You should write down 4 significant figures. 4 significant figures. 4 significant figures. All right. So yeah, the answer here is going to be 4 significant figures. That's agreed, because it's a multiplying. Okay. All right. Next, let's do this. So 60.11%. It means 60.11 divide by 100, multiply by 68.93. And that gives you 41.43. And leave. So this is the raw number as I see in the periodic table. In the calculator. Do not round up in between the steps. Okay. You only round up the last answer, final answer. It's just like I said, rounding up is just cosmetically making the numbers look beautiful. So anyway, so you have 41.43. All right. And then there's 41.433382 and blah, blah, blah. So just write down 41.43 as it is. As is. As is. As on calculator. I just wanted to keep this here. As on calculator. Okay. Next is 39.89 divide by 100 times 70.92. And what do you get here? 28.28999. So don't worry about anything. Just write down 28.28. Okay. There is 9 after the 8 also, but don't. Keep it as is. You see on the calculator. Next thing is, now since the question has to be based on the significant figures. Okay, so I'm going to put one more time. Based on the significant figures. Very important. Okay, so what is the rule here? Next thing, you are going to add. And whenever you add, what do? You look at the decimal places. Okay, so this is how many decimal places? 2 decimal places. How many decimal places? 2 decimal places. So here the answer should be 2 decimal places. All right, now let's do this. 41.43. 41.43 plus 28.28, and you get 69. So this is 69. So just write down the number first of all as it 69.71. So this is what I'm getting from the calculator. My calculator is showing that. So because we need 2 decimal places and we are seeing the 2 decimal places here, and no need to round up, no need to round down, nothing. That's what it is, you know. So you have this is going to be the number that is going to be posted on the periodic table. So the answer is the average isotopic mass for gallium is 69.71. Always write the unit. At this point, the unit is atomic mass unit. But when you go further, you will see grams per mole, you know, so be flexible with that. So 69.71 can also be written as grams per mole. You will be using this in the future, okay? Commonly used. This is more common now, but we need to. So, okay, so this is what you should know. Next comes just the things about the orbitals. Okay, the information about the orbitals. So, here, orbitals. So, second, the information about the subshells, right? Orbitals and the number of electrons. Okay, so if you have, what's that called? And let's do the energy level also. So you get that. Energy levels or the shells. So energy level. And this energy level is also called a shell, subshell, orbitals, and the number of electrons that can be held. Okay, and the number of electrons. So you should know that in this case, you should know if the energy level is first energy level, the subshell is called 1s. Okay, 1s. 1s, the orbitals is also called 1s, right? A 1s, and the number of electrons are 2 electrons. All right. Then comes the energy level 2. You should know that energy level 2 contains 2 subshells. And those 2 subshells are 2s and 2p. The orbitals. S will have only one orbital, and the name of that orbital is 2s. And the name of the p orbitals, there are 3 orbitals, and the name is 2p. So there is only one subshell. There are 3 subshells, 3 subshells. Sorry, no. These are the orbitals. One orbital, and this is the 3 orbitals. Okay. One orbital contains 2 electrons. The 3 p orbitals contain a total of 6 electrons. Okay. Then the third energy level has 3 subshells, right? So let's put it here, 2, and then 3. So this part is here. And this is the information about the orbitals. So one orbital. Okay, and then this is the information about the electrons. So 3s, 3p, and 3d. All right. So 3s contains 1 orbital. P orbitals are 3 orbitals. D orbitals are 5 orbitals. Names are 3s, 3p, and 3d. S can hold a maximum of 2 electrons. P can hold a maximum of 6 electrons. D can hold a maximum of 10 electrons. Okay. Now we have, then comes the F, 4. 4 contains 4 subshells. The names are 4s, 4p, 4d, and 4f. Okay. Now 4s contains 1 orbital, p contains 3 orbitals, d contains 5 orbitals, and F contains 7 orbitals. The names are 4s, 4p, 4d, and 4f. So you see the subshell name and the orbital name is the same. But the only thing is that the orbitals, the numbers, the amount is different. So S can hold a maximum of 2 electrons, P is maximum 6, D a maximum of 10, and F a maximum of 14 electrons. So you should know these basics. Okay. Next thing that I told you, because this in your book, this is in your book or in your handout is given like, in that zigzag fashion, and that zigzag fashion, if it works for you, good, you use it. But you should know the filling. And like I said, you can put a note of it in your handouts. Filling of electrons, then order. Okay, so you have to follow that order for filling of the electrons. So let's do that. Following the order for filling of the electrons. Let's see. Here, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, right? And then comes 3d10, and then comes 4p6, 4p6. Okay, after that, what comes after that? Tell me.
5s2.
Very good. After 5s2 is?
4d10.
Very good. 4d10. And after 4d10 is?
5p6.
Very good. After 5p6 is?
6s2.
6s2. After 6s2 is?
5d10.
4f14. Remember, 4 has got f also. 4f14, then comes 5d10. And after 5d10 is 6p6. After 6p6 is 7s2, right? And after 7s2 and so forth, you can just, keep going from there. Like 5f14, then 6d10, and then 7p6 and so forth. So, but I won't give you like that, that much. But let's look at now the example, some of the examples of the electronic configurations. So I can give you, write the electronic configuration of, let us say tin, SN. Okay. So what number do you need here? What number will you need? Tin. You would need the atomic number. And what number is that? 50. All right. So now in this case, so this is one example. This is one example. Okay. So 50. So, so what we'll do? 1s2, 2s2, 2p6. Now, first of all, let's say, where are we going to stop? Well, let's do the placement, first of all, because then I don't want you to placement. What is a placement? Placement. It's best to always do the placement so you know where to stop. So the placement is that tin is present in 1, 2, 3, 4, 5. Fifth period, right? Which block is that? Which block? P block, right? P block. And then which column in the P block? Second column. Okay, second column in P block. So this, the placement is, it is going to end in 5p2. This is where you will stop. So let's do it now. You can follow. Like I said, it's the easiest thing I've found the students, if they write this on their handout, it's very easy to just keep doing. So you would need all the way till 5p. And then 5p, maximum 6 are there. It can be held 6, but you only need to place 2. So you only place 2. Okay, so let's do this. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6.
Wait, Professor?
Yeah.
So I got a question.
Yeah.
So when we do the test, do we gotta show the work, placement, fifth period,
Yes, exactly. Yeah. You have to do all of this. The filling of the order of filling. Like I'm saying, multiple choice can be very you can just, I know students like multiple choice, so we give multiple choice, but we expect you to show us how did you reach that answer. So you have to show the working. This is working. Okay. Show this. This is your working. Okay. And if this is not shown and some multiple choice is just randomly clicked, no points for that. All right. Okay. Now let's do this here. So, okay. So how do we do this now? 1s2, 2s2. See, why would I show you this? Why am I doing this for you? You see that? I am expecting you to write down all these things. All right. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2. After 5s2 is 4d10 and 5p6. Okay. Now, here is a very interesting part. So this is the ground state electronic configuration. This is the ground state, normal ground state electronic configuration. Okay. Just the ground state. But if they are asking you, write the condensed. And the condensed is also called the noble gas configuration, right? Noble gas electronic configuration. So how do you do this one? You're going to now check the number of electrons that match with the noble gas one period above. So look at this: 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 6, 18, plus 2, 20, plus 10, 30, plus 6, 36. 36 match with krypton. So all this inner core is all these guys from here to here, all of them, these 36. This is still here. All this here till here is 36 electrons. Okay, and then just add more just so you have them all right. So 36 plus 2, 38 plus 10. Plus 10 is, oh, wait, sorry, I made a mistake here. It should be 5p2. Okay, 5p2. Okay, so 36 plus 2, 38 plus 10, 48 plus 2, 50. So all these numbers are matching. These numbers are matching with this number. That's one thing. Next, the placement 5p2, right? That's the placement in the periodic table. In periodic table. All right. Next, let's write down the condensed noble gas configuration. Condensed is square brackets 36. So that is krypton. And I like to write down the electrons. So kryptons, 36 electrons. The leftover, you write down like that as you have in the electronic configuration. 5s2, 4d10, and 5p2. All right. 5s2, 4d10, and 5p2. So now that's the noble gas. So this is one type of question. This is another type of question. Okay, now more. Let's look at the question that can be asked is, write down what are the valence electrons. Valence electrons. So which ones are the valence electrons? Tell me. Valence electrons, which ones? Valence electrons are always the highest shell number. So now tell me which one is the highest shell number or energy level. Let's look here. Shell. Okay. Okay, I got your answers. It's good. Like, I come to know if there's something you guys are. Okay. So highest shell number is 5. 5 is the highest, the largest, the biggest. Like, it's also called the biggest, if that's the word you understand. Biggest shell number. So you see there is 4 and 5 in this case, right? You get that, Ernesto? So it is 5 here, 4 here, 5 here. Maybe you're looking at the orbitals. You're looking at this 10. No, it's the 4d10. What is the meaning of this? This means 4 is the shell number, the energy level. This is the energy level. D is the orbital. orbital, d orbital. And 10 represents the number of electrons in the d orbital. Okay, so that's not the highest. The highest is the other one, 5s2 and 5p2. So here you see 5 is the highest, largest, or the biggest. Okay, 5 is the highest shell number. Okay, and the number of electrons is 2 plus 2 is equal to 4. So these are the valence electrons. So you see here that the valence electrons are the ones that are present in the highest shell number, 5, and it's the total number of electrons. So 4. So that's the valence electrons in this case are the 4. Get it, everyone? So this type of question can be asked. Okay, this is a
Professor,
test question.
Yeah, I have a question.
Yeah, go ahead.
Yes. So regarding the crypto, why do you stop at crypto? Can you just continue to go? Because if we go 2 step,
No, it has to be the only nearest noble gas.
I see. Okay.
There's no nearest noble gas. The next one is xenon. And xenon is 54, but that is above zinc. So we obviously cannot put xenon because xenon is 54 and we only have 50 electrons.
Okay, so only noble gas. Got it. Yeah.
Yeah, it's the nearest noble gas, and it's always nearest noble gas, one period above. So, if that helps. Okay. Next is the, so that's the valence shell, valence electrons. Everyone get that? So this type of question can be asked. What else? Orbital diagrams, orbital diagrams. Let's do some orbital diagrams of like we have copper and chromium. Okay, let's do this one. Chromium. I already did copper in the class. So 1 and then 2. 2. Chromium. Okay, and chromium is 24. So chromium 24 is present in, now the placement of chromium, Cr, is in the 1, 2, 3, 4. Fourth column, right? D block, and in the fourth column, D block, and in the in the third, like it's like third row. So that's the transition elements. Actually, it is a fourth row, but 3D, that's where it is. So it is in 3D placement, 3D, and it is actually the fourth row. 3D is in the fourth row or fourth period. Okay, so this would be 3D4. Now let's do this. 1s2, 2s2, 2p6, 3s2, 3p6. After 3p6 is 4s2 and 4s2, and after 4s2 is 3d4, and you stop, right? That's the last. So if you count 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 6, 18, 18. And then 2 is 20 and 4 is 24. But 18 matches with the inner core. These are called the inner core. Inner core. And this inner core is that of argon. The inner core electrons, argon, 18. All right. And then the leftover, you write down 4s2 and 3d4. Clear? Now let's do the orbital diagram. So that is also another question that will be asked. So orbital diagrams are D. How many orbitals are there in D? 5. So 1, 2, 3, 4, 5. So this is 3d4 and this is 4s2. Now, filling of orbitals, singly occupy first. So 4s2 is this and 3d4, 1, 2, 3, and 4, right? So the rule is that half filled and fully filled. Fully filled orbitals are more stable. More stable. Okay? So now, is this half filled? Is D half filled? Is D half filled? Yeah. Tell me, is D looking half filled? No. Right? Good. So it is not half filled. So what is going to happen? So in this case, D is not half filled. It has only 4. D prefers to have 5. D prefers to have 5. Therefore, what is going to happen? 1 electron jumps from 4s to 3d. Okay, so this 1 electron, which is this one, this jumps and comes here. Okay, and when that happens, now we have half filled. So after all this internal jumping, rearranged electrons. So what do we have? So we have argon, 18. These don't move. These are stuck. Inner core. This is the 4s1 and this becomes 3d5. So 1, 2, 3, 4, 5. See, the total electrons is not changing. It is the same. So D, the only thing is its stability. 1, 2, 3, 4, 5. You see how I'm filling up the orbitals? So this is the orbital diagrams are very important. So let me just erase this here. So they can see, you can see, you can clearly see. So this is the orbital diagram. Orbital diagrams. So that helps you see, so this becomes more stable, half filled. Okay, so it sees. So this is something. Yeah. Okay. Okay, guys. Any questions on this? And we are going to study further, like in the next chapters, like how the electrons are given away and how the electrons are how many are given and how many are not, all the octet rule. Okay, another type of question that can be asked is, I will give you the electronic configurations, okay, and I'll ask you to find out they belong to which. So, the rest is just practice. Orbital diagrams also very important. So on the test. All right. Okay, so those people who need a little more help, they can stay after the review in the, office hours, and then we can go more one-on-one, specific problems, doubts, but we need to cover things. So we have to just wanted to give you a big, brushing up on everything. Okay, next is the third Third one is I can give you like some like messed up, like let's say this one. Now tell me, which one is this? There's argon, 4s2 and 3d5. So tell me, this is given to you. This belongs to which element? Number of ways you can do this. Yeah. Belong to which element? This type of question can be asked. And actually, not asked, I have them. So just to see. Okay. Yeah. Which ones? There are few ways you can do. Argon. How many electrons does argon have? Look in the periodic table. Argon has 18 electrons. Okay. So 18 electrons are here, plus 2 are coming from 4s2. And then 5 are coming from the D, right? So add this up. So this becomes how much? 25 electrons. So which element? So look at that element that has the atomic mass of 25. Atomic mass of 25. So which one is that? Manganese. Very good. So manganese. So look in the periodic table. Look in periodic table and you will see manganese has 25. So this is of that. This is one way of doing it. This is one way. Next way, or you can simply look at the placement. But it's not like sometimes, in multiple choice, we give you wrong answers also. So you have to be careful with that. But that's one way you can check also if you want to. Here, you can look at the placement. So if you look at manganese, manganese is present in 3D and 5th column. So it is present in, the 3rd row, the 3rd row, but, actually the 4th row. But the D block starts at 3D, right? And then this is the D block. And this is the 5th column. 5th column. All right. So that's another way, you can look at this piece right here. So that's one thing. Okay. Next thing I can give you, let's do a few more examples here so that you guys can. Okay, let's do this one. A and then the B. Okay. 1s2, 2s2, 2p6, 3s2, and 3p4. Tell me which one. 3p4. Which of the elements is this? Selenium? It's not, so pay attention to the symbols. It should be correct. See, that's what I'm saying. Multiple choice, we can give you. Okay, let me do this. This belongs to this. Does this belong to this? Does this belong to P? Does this belong to
The first
CL?
option, right?
Which one?
First one.
The sulfur, right?
Yeah.
It's sulfur. So how do you know it's sulfur? 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 4, 16. So this is total 16 electrons. And the placement is all right. So sulfur is the one with the 16 electrons. Selenium is 34 electrons. So this is not the answer. This is the only answer. Phosphorus is 15 electrons. So if you're not counting, you may mark phosphorus. If you're not counting correct, you may mark chlorine also. So it depends on your counting. Okay, 16 electrons belong to sulfur. So that's what it is. Okay. Yeah, and also the Lewis structures. Lewis structures. Lewis structures is the last electron, the valence electrons. So in this case, which are the valence electrons? Total 16 is fine. Which one is the valence? The last electrons, which ones? This is the total last. So the third shell is the last shell. So valence electrons are in the valence shell. So in other words, you have the sulfur 16. The inner core is like neon, those 10 electrons neon. And then you have 3s2 and 3p4. So a total is 6 electrons. These ones. Total. It's always the total of this. This is the valence shell. Valence shell. And so these 6 electrons, how do you show? You take S, 1, 2, 3, 4, 5, 6. That's the Lewis structure. Clear? In manganese, which is the valence electrons? Manganese. Just now you identify manganese. Valence electrons, which ones? Manganese, valence electrons are? Remember, largest shell number. Which is the highest shell number in manganese?
Before.
Which one?
Hold on.
Shell. The shell is the big number that is written in front. The row. The one that depicts the row. This is the shell number. Okay. So which is in manganese, which is the shell number? Valence electrons are where? Come on, guys. Valence electrons are the last electrons. So the highest shell is 4. Yes, exactly. And the highest shell is 4 and it has got 2 electrons. So the highest valence electrons are 4s2. So there are 2 valence electrons, these ones in 4s. Okay. And right. So, I mean, I know it can be a little bit confusing. But it's the, it's the 3D is it's just the filling of the electrons, but 4s is still the last shell. Okay, this is still the last shell, the highest shell number. So 4s2, fourth is the energy level, and S is it's present in D block, but it's the outermost is 4s still. So 2 electrons. All right. Now, next is the chromium. Same story with the chromium. 4s is the last shell. So 2 valence electrons, chromium. And in this case, tin. So tin, how many valence electrons? We talked about this, the highest shell number. Yeah. So we already discussed these are the 5s and 5p. Add together because in the same energy level. So 5s and 5p, 4 valence electrons. Okay. So want to do one more? Let's do one more. And then we will do the trends after that. Okay. I'll give you one more and then you guys do that one. Okay, tell me this one. Neon. Oh, this one I already did. Hold on. Yeah, let's do this one. Helium, and 2s2 and 2p5. Which one? 2s2, 2p5. Which one? Identify the element. So here you see, helium is what? Helium is 1s2, 2s2 and 2p5. Which one? Come on, guys. So 5 plus 2, 7 plus 2, 9, right? So 9 electrons, and these belong to the atomic number of fluorine. Okay, now fluorine is not Fl, fluorine is just F. Okay, so that's the atomic number. So check with the atomic number, and you can look at the placement also. Second row or period or energy level, P block, and in the P block and in the P block and in the fifth column, and you will find fluorine. Okay, so that's one piece. Now valence electrons here. Valence shell. Which is the valence shell? And how many valence electrons are there? And what is the Lewis structure?
Would it be 2s2 and 2p5?
Both of them combined together, yeah. So the valence shell is the second shell, right? The second energy level. And in that, we have 2 plus 5 equals total of 7 electrons. So it's always you combine them. But if they have to be in the same energy level. So same energy level, and that is 2 plus 5 in the same. If it is different energy levels, then you don't, you leave them. But they are the same energy levels. So you count them, okay? So the second energy level and okay. Lewis structure. Lewis structure is fluorine, and then just put the 7 electrons. Put the 7 electrons. No. 1, 2, 3, 4, 5, 6, and 7. All right. So always the Lewis structure shows the valence electrons. So we covered all this. So, you know, electronic configuration, I went over. And then the last is the, the trends in the periodic table. Now, ideally you should memorize, but if you don't, then the size is the radius. So radius, this is also in your handout. The radius goes down, right? The size decreases when you go left to right in the periodic table. And when you move in the same column, top to bottom, top down, the size goes up. So this is one piece. So if I give you two atoms and compare, so tell me, carbon versus fluorine, which one is bigger in size? carbon or fluorine? Carbon is in group 4A, fluorine is in 7A, so different groups. And if you move it in the same, but they're in the same period. So when you look in the same period, they are going to, we see that carbon is bigger in size than fluorine. And the reason is the nuclear pull is the reason. The more the nuclear pull in the same period, the nuclear pull, what does the nuclear pull do? It condenses the electron cloud. Condenses the electron cloud. Electron cloud like gets squished, and that affects the radial size. Okay. Now, if I give you another example, find like magnesium versus strontium. Magnesium versus strontium. So magnesium is bigger, right? Is smaller, but strontium is down. So strontium is bigger. Magnesium is smaller, strontium is bigger. So generally students, they do it fine here. They don't mess up because these are given in your handout also. Next is look at the ionization energy. Ionization. Ionization is removal of electron. Ionization energy relates to removal of electron. How much energy is needed to remove an electron from its outer, energy level? So ionization energy also refers to ionization potential, and it also refers to electronegativity. Electronegativity. And this also refers to electron affinity. Electron affinity. Electron affinity. Okay, so here you see that the so we can write this down as IE, and electronegativity is EN, and electron affinity is EA. So the trend in the periodic table is going from left to right. Left to right. The ionization energy increases. Okay, electronegativity increases, and electron affinity also increase. So you see all these are connected. But top down, going from top to bottom, what do you see? The ionization energy decreases. I mean, it's easy to remove the electrons. Electronegativity, that is the love for the electron, decreases. Obviously, it's easy to remove them. Love or the attraction for the electrons is minimum. So that is why it's easy to remove them. So if I give you a question, nitrogen versus phosphorus, which one has a higher? Nitrogen versus phosphorus, which one has a higher ionization energy? So nitrogen is on the top, phosphorus is at the bottom. So nitrogen will have a higher. So this is on the top, this is on the second row. Second row. And phosphorus is on the third row. So the lower, the bigger the row is, top down, it's easy to remove the electrons. So, but nitrogen, it will be difficult to remove the electrons. So let's look at another one. Let's see, beryllium versus oxygen. So in this case, very difficult to remove electrons from oxygen. So beryllium has a lower ionization energy than oxygen. Same row, these are in the same row, same period, but more protons, more nuclear pull. Oxygen will have more nuclear pull, more protons. So all this has been explained, in the lecture. So just watch those videos if you want to, review those. But more the nucleus, more the nuclear pull, the stronger the more the nuclear pull, the stronger will be the the ionization energy, the stronger would be the electron affinity. So the electrons cannot be removed easily. Okay. Okay, so these things, and then comes the metallic character, the last one. Okay, so here we got this size. Then we have the ionization energy and then those things. And then comes the metallic character. Okay, metallic character. Now here in this metallic character, as you already know, that the metals, more metals are on the left-hand side and non-metals are all on the right-hand side. So left to right. So here the metallic character decreases, MC. The metallic character comes down. You know, ability. What is a metallic character? Ability to conduct electricity, heat, right? They have very high tensile strength. In other words, they are malleable, they are ductile, those things. So non-metals are on the right-hand side. Then the metals are on the left-hand side. So the metallic character increases, top down. And here we have left to right. Okay, guys, so this finishes, right? And just know the properties of metals. So know the properties of and non-metals. Okay, so this finishes, and we covered a lot of things here. And if you guys have to stay to discuss some other stuff, you can. But I really have to apologize for the sound of the dog. This little one is a little puppy and he barks a lot. So I'm so sorry about that. So, but I hope it didn't show up too much in the recording, but let's see. All right, guys, any other questions you guys have? All good? Okay, I'm going to stop recording, and you guys can stay behind if you have any questions. Okay, thank you so much.